mode.
Hi, welcome everybody. It's been a while, but we are doing an activity webinar this month. My name's Lee Johnson, if you haven't been to an activity webinar before with Cause. Today we're talking with André Lubecke from Lander University. And so I'm going to just go ahead and let you take it away. André?
Thank you. I teach at a small liberal arts class, and the classes that I'm teaching are generally no more than 25 to 28 students. So I'm in a pretty good situation to be able to do something in the classroom. I love sharing ideas with other educators because you never know what they're going to do with them. They can take one thing you say and turn it into 5 or 10 other things.
André?
Yes.
I'm sorry, I'm going to interrupt you. You kind of are moving away from your mic a little bit, so it's hard to hear you.
Okay, I'll try to stay very still here. Okay? All right. So my self-assigned duty for the day is to try to offer you a sampler plate of what I'm calling bite-sized ideas that you might use to create your own memorable classroom experiences. And I promise they're low-tech and low-cost, and they don't take a lot of time to do in the classroom. But first, I want to share with you 2 principles that I live by when I am doing things in the classroom. And my first one is to be brave. Act on a good idea. So if I think something's a good idea, I'm going to act on it whether or not I have a formal activity developed. Developing formal activities is a process, and it's not always necessary. Many of the things I'm going to talk about today, I don't have written up anywhere. I just go into the classroom and actually do. The first time I started doing things in the classroom was probably back in the late 80s. I was very bored with the way I was teaching probability in our entry-level statistics class, and I thought if I was bored, my students were going to be bored too. So I went to my department chair and I said, can I bring some dice and some cards into class and do things differently? And he said to me, sure, but if it doesn't work, never do it again. And that sounded like an odd thing for him to say, but in retrospect, it was very freeing because he not only gave me permission to try something new in the classroom, he also gave me permission to fail. And that was a very safe feeling. And I can't say I followed it directly and didn't do things that didn't work. I did wind up tweaking them. But if I had a good idea, I bravely acted on them. My second principle is to have some fun. If you find something that you like, find a way to use it because your enthusiasm is going to be contagious. My favorite thing to do in life is play. I have a very playful spirit. If I can play in the classroom and the students are learning at the same time, I figure that's the best of both worlds. So where do you find ideas to do things? And I say you find them everywhere, which is why I am starting with my wooden farm animal puzzles. I found these at a little old-timey 5 and 10 type store. I think I was on vacation with my sister in Cape May, New Jersey, when I stumbled upon this little wooden box of wooden puzzles. And I picked them up and I said, oh, I'm going to use these in the classroom. My sister says, why are you buying those things? I said, I'm using them to teach. She says, no, you're not. What are you going to do with them? I said, well, I'm not really sure, but I'm going to use them in the classroom. She says, oh, you just like them and you want them. And it was true. I did like them. I did want them. But I had at least one thing in mind that I was going to do with them. And I've dubbed that my wooden puzzle activity number 1 today. I knew I was going to use them to generate a discussion of experimental design issues. So I bring my puzzles in, and I tell them how I came about getting them. And I say, okay, I want to know if some of these puzzles are easier to put together than others. What should I do? And then I just wait. And I let the conversation develop among the students as it will. I only prompt them if I absolutely have to. And I am amazed at how often so many of the ideas of experimental design come to them. We wind up talking about whether we want dependent samples or independent samples. They don't call them that, but that's what they're thinking about. Sometimes I even have to ask them, well, what are we going to measure? What can I measure that will get at this question? And someone has to verbalize, oh, we want the time to complete this puzzle. And it's nice, too, that they often think about randomization, that if they decide that everyone must put all 4 puzzles together, someone always says, well, what if it gets easier as you go along? What if do we always want the cow done first or the horse gun first. So let's randomize what's happening. So now we've got a situation that is very easy for them to look at. So they're only thinking about the design issues of the experiment. They don't have to worry about how complicated a situation it is. So when we go to more realistic questions, we've already thought about the design issues, and then I can talk about more realistic situations in which we might want to design an experiment. The second one that I've done with the puzzles is if it's in that class that we're also later doing comparison of multiple means, I will bring this back and I will look at the experiment they designed early in the semester, and we will often run the experiment. I have my students work together on group projects a lot. So during the day, one day when they are doing group projects, the students came back to me one at a time at my puzzle station, and I timed all of them on all of the puzzles. At the end of that hour, I had my data collected. I posted it for them to analyze before the next class period, and I actually had a really nice discussion with them in the class results the next day. You'll see a note on my slide that says curious gender differences. If we have time later, I will come back and tell you about those. Then I've got puzzle activity number 3. This came up because there was an exercise in the textbook we were using that had to do whether learning took place when someone did something twice, or there was a before and after time period. And so I thought, I can do that. This particular semester, we had some snow days. One of my classes was a few days short of the other, so I wanted to do something meaningful in the one group that I could maybe bring into the other. So I brought my puzzles back in. I collected the data again during one class period, so in an hour's worth of time. This time, the students worked in pairs. The student pairs were randomized to the puzzle station. So I had 2 puzzles at one station, 2 puzzles at the other. When they got to the station, the students flipped coins to randomize who was doing which puzzle, and then they either rolled the die or tossed the coin again to decide who was going first. They timed each other. Those not working at the puzzle stations were again completing a group assignment. I posted the data for the students to analyze. You okay?
I'm sorry. We're having trouble with the sound again. It kind of comes in and out. I'm not sure what's happening. So just try to be a little bit closer to your screen.
Okay, I will do that. All right. So the nice thing that happened with this particular set of data is that it actually wound up demonstrating something we often talk about. And I put some results up here for you. Did learning take place? Yes. The average difference in time was they were 18 seconds faster the second time. This was statistically significant, but here was the really interesting thing why I liked the data. The individual times for the first trial and the second trial are very right skewed, as you can see from the pictures that are up here. But when you look at the differences, they were fairly symmetric and nicely unimodal, and we could talk about, oh, look, they do almost look like a normal distribution. So the things that we talk about should happen with the differences actually happened here, and it was very nice for the students to see this. What turned out to be kind of curious, and here's my puzzling statistics, is when I broke down these times according to the actual animal puzzles that they were putting together, the p-values for whether learning took place were all over the board. It was very nice because it was the end of the semester, and I can use this example to talk about the difference between things being statistically significant or not statistically significant. And it was the data that they had generated themselves, so it was meaningful to them. So that was a very nice thing for me to do with the puzzles. Well, what if you don't have my little 12-piece puzzles that only took about a minute or a minute and a half to put together? What do? And I say you use what you have creatively. Use your students. Use their playfulness. If they're playing in the class, they feel like they're getting away with something, even though they're learning. And I also like to use their zest for competition. If they think they are competing with each other or with a clock, they are willing to do almost anything that I ask them to do. Also say, use handy items. Stopwatch that my students can use, but they also have them on their cell phone. So if you want to time something, you can easily have them time things on their cell phone. My next nice little experiment I used dice for. I was looking for something to wake up an 8 o'clock in the morning class. They hardly like to get active first thing in the morning, so if I could find them things to do very early in the class period, it perked them up. So I came up with this dice stacking experiment. I have all different kinds of dice of all different sizes. I've got decks and decks of cards, so I thought, well, let's deal some cards. Not a whole deck. I think I was counted maybe 24 cards into hands of four hands of 6 cards each, and you can see my stopwatches in the background there. And I wanted to do something with multiple meanings, so I wanted more than 2. So I said, oh, we all have voices. Let's say the alphabet. So my 3-task experiment was born. And this is the data sheet I created for it. Each student did the task 3 times. They worked in pairs, timing each other. You can see I collected some data about their gender and what was the fastest or the slowest. Sometimes I used it, sometimes I didn't. I'm showing you the results of what happened in one of my classes for the reason that this is taking very little time. Each one of these exercises or experiments takes less than 10 seconds to do. So if you say, I don't have time to do real experiments in the classroom, there's one that you do. It only takes 10 seconds for somebody to run an experiment, and you get some good data within 30 minutes worth of time. Here's part 2 of use what you have creatively. You've got some campus and also personal resources. I've got a backyard full of pine cones. We all get textbooks sent to us. Maybe you've got a backyard full of stones. My science folks gave us some calipers to use. They gave us some springs to use. We bought some scales. I had a student design an excellent experiment using the resistors in the physics lab. My PE friends, they had bean bags and hula hoops and balls. I haven't borrowed them yet, but I'm going to find something to do with those with my students. We generally all have rulers and meter sticks, and tape measures, the kind you use for sewing, are very cheap to buy. Plus, we have student bodies, and I mean this literally. So I have a few what I call my student body experiments. I go into class one day, and I actually ask them this question about Pretty Woman. What does Julia Roberts' character say to Richard Gere's character shortly getting into the car with him at the beginning of the movie? Now, sometimes they kind of know the movie, but sometimes they don't remember this. What she claims is that the length of a person's forearm is the same as the length of their foot. So we start talking about what other kinds of bodily measurements might be correlated with each other. And we developed a correlation and regression lab based on these, what I'm calling a physiological data. So the individual data sheet that you see on the left, every student has one of these. They are assigned student numbers, so we're not going by names. It takes not too long to measure these different lengths with either the tape measure or the ruler or a yardstick. And then what I do is we pass these individual data sheets around the room so that everybody winds up with 8 or 10 observations, and I try to help get them distributed around the class so that the ones sitting next to each other don't have the same data. And we look for things that are correlated. The other thing that is really interesting, and I don't know whether you know this, but if you look at the ratio of a person's height, the distance from their navel to the floor, it's supposed to be the golden ratio. So that's a very nice thing to see if it actually shows up. And I've also done correlation labs with my pine cones that are in my backyard, and even with the textbooks, where we measure the thickness of the textbooks and the number of pages and the diagonal of the textbook. So you create lots of correlation and regression labs. I have them predict the height of a mystery person based on their most highly correlated value to a person's height, and that's usually one of the other faculty members that I've gotten data from. So it's kind of like that one. Here's my student body experiment too. I did this in my sleepy class at 8 a.m. because it was a class in which I was trying to look at some chi-square examples. And so I walked into class one day and said, okay, today we're going to see how long you can stand on one foot with your hands folded in front of you. So I demonstrated how they're going to interlock their fingers and hold them at their waist, and then stand on one foot. Turn my stopwatch on, tell them to go. Now I've got all my students standing on one foot with their hands clasped in front of them. Then I start talking to them. Well, I don't really care how long you're going to stand on one of your feet. What I care about is which foot you're standing on and which thumb happens to be on top when you fold your hands. So look down and pay attention. Which foot are you standing on, and which thumb do you have on top? And then I start talking about hand dominance and eye dominance too, and then I usually say, and how many of you are still standing on one foot? And generally they are, because that stopwatch is still running behind me on the overhead. So we sit down, and then I get all these other things. They look at hand dominance. Many of them have never heard of eye dominance, so we figure out their eye dominance. And I put together all these little 2x2 tables that we now have some real data from them that I can accumulate and put together maybe from semester to semester, so my sample size keeps getting larger and larger, and we look and see what happens to be related to what other measurements. One of my favorite days of the semester just happened last week. We came back from spring break, and I had sampling distribution day. So I bring out everything I can think of. I've got my government-issued tax. Those dice in the upper right-hand corner are from Caesars Casino in Atlantic City. They poke holes through them, their dice, when they pull them off the floor and sell them in their souvenir shop. They actually sent me some dice when I asked for them, told them I wanted to use them for a presentation. Here's my stones. And so I create lots of different stations around the room. We bought BBs. This BB sampling bowl cost us maybe $30 to put together. A colleague and I counted all 20,300 beads that are in there. I actually had the sampling paddle, so I didn't have to purchase them. But sampling distribution stations are set up around the room, and you can kind of see what we are looking at. They're dropping packs 20 at a time onto a piece of felt. They have my casino dice. I've got the BB bowls. I have chips that are supposed to mimic a normal distribution. I have another bead bowl. We've got the stones and the seashells that they are putting on scales. And I'm going to tell you what's on the next page, next slide, while you're kind of looking through the list. Students work in pairs. My stopwatch is up again because they are spending 4 minutes per station. We do 6 to 8 rotations, so in about 40 minutes, I wind up with a good bit of data. At the end of the data collection, and let's see, I just told you what was on here. My students pick up these data collection sheets. So every pair or every one of them has one of the data collection sheets. I promised it was very low tech. You can see they're just marking it up as they get their observations. I blew up the one on the left because I kind of liked it. Students got a little creative here. I've got faces of different kinds and flowers, and so they're looking. They have done the counts. Right below it, I've got the percentages. So they put this data into our stat software, and we can very quickly get means and standard deviations. What we're doing then is, by the end of that hour, we're comparing the average value of our observed sample proportions to the theoretical values when we know what should happen, like the proportion of odds or the proportion of, I don't think I do heads, but we know some of the proportions. We can compare standard deviations of these p-hats in the same experiment, but with different sample sizes. At one place, they tossed 10 dice. At another place, they tossed 20 dice and looked for the number of odds that they had, so we can see the standard deviation is getting smaller for the larger sample sizes. And then we can say, okay, I see it's gathering themselves up around the right values when I know what the true proportion is, so I am trusting that the p-hat values are gathering themselves up around the true proportion of times that attack is going to land point up, which we obviously don't know. So we talk about how we then can trust what we do when we've got one observation, or we know the sampling distribution, how it behaves for real, when I know the theoretical ones, and now how I can generalize this to a situation where I don't really know what the true proportion is. Because I'm in a computer classroom, I have my students at computers, and we did buy some nice scales. So I've got 2 students sitting side by side. One of them is putting 9 shells at a time on the scale. One of them is putting 4 shells at a time on the scale. They are saving the data file to a place where I have access to it from my teacher station. So by the end of the class period, I can pull up pictures that look like this. And we can look at the distribution that we got for sample means for 4 shells at a time, compare it to the distribution of sample means for can see the variability has decreased with the 9 shells. You can see they're gathering themselves up at about the same value. That 1.8 seems to be pretty standard. The semester date was at 1.81. And we can see that the standard deviation of the sample means in both cases is providing about the same estimate for the standard deviation of the population. If you multiply this one by 2, you get the same thing as if you multiply this one by 3. So even though I don't know what the population of shells weight really looks like, I can assume that it's right skewed because this one is. I can guess that the average weight of the shell is about 1.8, and I know about what the standard deviation looks like, 0.92 or 93. So I've only served up a few little ideas for you, and I'm just kind of going to recap here. Don't forget to be adventurous when you're putting things together for your students. Have some fun with it, and enjoy the unexpected. And when something really nice happens, save the data so that you can use it again in some of your future classes. So pick up those cards and those dice and those hats and anything that you have handy and create some things to put on your own menu. And I hope that you can use some of these bite-sized ideas in some of your classes. And I thank you for joining me today.
Well, thank you, André. I do apologize to everyone. We were having a little trouble with the sound. Hopefully you were able to hear for most of it. If anyone has questions for André, if you'd like to type them in the question window, I can relay those for you. Okay. Thank you, Michael. Said the sound was okay for most of it. So how many students do you typically have, André?
We teach in a computer classroom which has 30 stations in it. We try to keep at least 2 empty, so in case something goes wrong, no more than 28, which is very nice.
Oh, okay. And then what data analysis package do you use with your students?
We use JUMP. I chose JUMP when we moved into this computer room. I went from like a $12 handheld calculator. I never used a TI anything that had the stat functions in it. So I went from a handheld calculator to computers. And I looked for software, and I wanted something that I could do a lot on without reading a word of instructions, and that led me kind of to JUMP.
All right. Well, doesn't look like we have any other questions. We'll give everybody, oh, sorry, hold on. Jeff Whitner would like to know what variables are related to eye dominance in the stand on 1 foot data.
I would have to go hunt for the data to find that out. But the neat thing is, it doesn't take long to do this, so you can go and run the experiment yourself and figure that one out. But I don't think anything was, I didn't have any strong relationships with any of those things, which was kind of surprising to me that none of those things seem to be very strongly related.
So what exactly is eye dominance? For those of us who don't know.
Yeah. What you need to do is you make a sort of a window with, like forward your fingers, make a small window with your index fingers and your thumb, and look at something that's a reasonable distance away from you, but is fairly small. And if you alternately close your eyes, the image, whatever you're focusing on, should disappear from the window for one of your eyes and should stay there for your eye that is dominant. I happen to be left eye dominant and left foot dominant, which is sort of an odd combination. So some things occur in more frequent pairs than others we observe. But, it wasn't terribly strong in anything. And I remember, I would have to go pull that data up.
Oh, okay.
Just not doing that.
We're starting to lose you again here a little bit. John McKenzie did want to know, what were the curious gender differences?
Oh, I wish I could demonstrate this. I know, John. Hi, John. What was very curious was the first student that came up and did the puzzles for me, when I told her to go, every one of the 12 puzzle pieces got turned over immediately, and she's very quickly putting things together, and it was obvious that she was being timed and done. And the second person that came up, and I said, go. And all the puzzle pieces got turned over quickly, and we're trying to arrange them and put the corners together, and we've got all this and done. And by the time I got to about the fourth person comes up, and all of a sudden I say, go. and one piece gets turned over, and a second piece gets turned over, and we look at those and see if they match in any way. Then we turn over the third piece, and now I'm sort of smiling because this is entirely different from what I've seen before. The next person comes up, the same thing. I say, go. They turn over three pieces and see if they kind of fit together, and they turn over the fourth piece and see if it fits together, and guess what genders those last two were? Every male in my class did not even act as if they were being timed. They slowly turned things over, and they tried to put together the pieces that were visible before they turned anything else over. Every single female acted as if the house was on fire, and she had to finish the puzzle before she got out. Everything got turned over, and things got pushed around and went again very quickly. I was absolutely amazed that every one of each gender behaved the same when they put those puzzles in front of me. It wasn't a timer that was making any difference. I was really curious.
There was a question about where you could buy the paddle for the sampling that was shown in the little beads.
That, I'm not really sure that. I'm trying to see, let's see how far down I have to go. I've had a couple of these. I don't have a picture of, I have a big bead bowl that I bought many, many years ago. It was over $600 at the time with all of these supposedly very carefully manufactured beads that all had the same weight and the same density, and they were supposed to mix very nicely. And that came with two of those clear paddles that you see. Somebody had a set of, I've got some dark green ones too. I have no clue where they came from. I can try to find out and see if I can get that information out. But I inherited some, and I bought, and I had some with this big bead bowl that I purchased for over $600 because it was so nicely weighted. And my BBs work just as well.
Okay. All right. Well, I think we've managed to answer all the questions. So again, thank you, Andre, for taking time to do this today. It was very interesting. Just a quick reminder to everyone that the April 1st deadline for early bird registration is coming up for USCOTS. If you need information on that, go to www.causeweb.org/USCOTS, and you'll see all the information about the upcoming conference. Hope to see many of you.
And if anybody creates some nice experiments that I can use in my class that are cheap and low time, you've got my email in there and you have my phone number, please let me know what you've done or how you keep things that I've thrown out to you today, and give me some things that I can work with too.
Okay. All right. So have a good afternoon, everyone.